So this is efficiency. Efficiency is basically output over input, right? What you want divided by what you pay, right? So the efficiency of a gasoline engine might be the energy in the gasoline, right? Right, and the output is the mechanical work that the car can do. Right? If we're talking about your furnace, right, the input is the energy in your natural gas, if you have a natural gas furnace, right? And the output is the heat that goes into your house. So it's really a matter of how you define it. If you look at, for a natural gas furnace, and you compare this to the total heat, what goes into the house and what goes up the flue and everything like that, well, it's almost 100% efficient. But if you take away the stuff that goes up the flue, up the chimney, right, and look at only the part that goes into the house, most gas furnaces are about 80% efficient, which means 20% of the heat goes up the flue. Some of them are like 95% efficient. Yeah? Yeah? Okay. What the 20% that's wasted on an 80% efficient furnace is not totally wasted, though it serves a purpose. Why is it good to have the exhaust gases of your furnace nice and hot? So they what? Yeah, it goes out the chimney. It's a rise up the chimney, or rather colder air pushes them up the chimney because they're less dense, right? And this is a good thing because the exhaust gases of your furnace have things like carbon monoxide in them, right? You know, and so in fact, your furnace has this clever system of checks and balances and stuff where it'll turn on, right? And the first thing it does is it tries to blow air up the vent, and if it can't blow air up the vent, it shuts everything down. And then if that checks, if it's like, okay, I can get air to go up the flue, right? Then it turns on this little thing that heats up really hot in front of the gas burners, and then it turns on the natural gas. And it checks to see if there's a flame, yeah? If there's no flame, it shuts everything down, because that's bad, right, to have natural gas going, no flame, yeah? Isn't that bad, right? Then it checks to see if when the flame is burning, that the heat is going in, and it measures the temperature of the heat exchanger, right? And when that gets to a certain temperature, then it turns on the big fan, blows stuff through the house. If it ever gets too hot, it shuts it. I mean, it's got all these things, right? And that's a good thing. How about the furnaces that are like 95% efficient? Does anybody have one of these really efficient furnaces? Here's something to check for tonight. Homework. Go home and see whether your flue, whether the exhaust gases from your furnace, do they go up through a chimney that goes vertically through the house, or do they go sideways out like here's your house, right? Okay. The really efficient ones, the furnace is in the basement, and the flue gases just go out sideways. In fact, there's a little fan that blows them out. They're so cold, they're just barely warm. They wouldn't rise up the chimney anyway. They'd kill you anyway. So they have a fan that blows those exhaust gases out the side. There's a little plastic pipe that runs sideways, should be tilted down, and the condensation sort of goes drip, 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 drip. So find out which one it is. When the furnace is going, is there stuff going out through the roof? That's probably 80% efficient. If it's going out through the side, if it's a real modern furnace, it's like 95% or greater efficiency. Water heaters, same thing. The water heaters that vent through the roof are not as efficient as the ones that vent sideways. But yeah, there we have it. Okay, examples. And of course, you know, the holy grail of perpetual motion machines, people want to come up with something that puts out more energy than you put in. This violates conservation of energy. We don't think it's possible. So here's an example. A 1 horsepower motor consumes 815 watts of power. Well, which one is input, which one's output?
Input is the 815.
815 is our input, and 1 horsepower is our output, right? So our efficiency is, well, a horsepower, I have to turn that into watts, so 1 horsepower is 745.7 watts. Yeah. So we're putting in this much electrical power, we're getting that much work out of it, and this is going to be 745.7. And this is 0.9149 or 91.5%, right? About, right? If you are a scientist, you're going to give it as just a pure number. If you are a journalist, you're going to give it as a percent. Yeah. Oh, we got Tanner. It's time to go to school. Yeah. So it's a pure number. It really doesn't have any units since it's power. It's watts divided by watts, or it's joules divided by joules, right? Let me. This is a slide from Mr. Duggan. Okay. This is the car. Apparently, it's a Ford Explorer. All cars are Ford Explorers or something like that, right? Okay. 100 units is the energy that we've got in the fuel. 33 units is lost out the exhaust. In what form do you suppose?
Heat. Gas.
Yeah, heat and unburned gas, right? In fact, that's what catalytic converters do. A lot of it doesn't burn. It's in partial combustion. Especially when the car is cold, it'll do that. 29 units is lost as heat in the cylinders. 38 units of that, 38% of that 100, right, is indicated in the horsepower of the engine. And then that doesn't include pumping the engine air. I don't know how you indicate the horsepower of the engine and don't include the energy needed. But maybe when you bench test it, you've got like something that provides the air. And I don't know. How do you not include the piston ring friction in this? I really don't know. I don't think that's exactly correct. And then accessories, right? If you turn on your headlights, right, your car's not going to be able to go as fast, or it's going to overheat a little bit. You turn on your air conditioning, et cetera, et cetera. You'll actually make the engine work harder. You'll get less gas mileage. And then, you know, a meager amount is actually propelling the car. So yeah, not terribly efficient. But yet, think about a gallon of gas. A gallon of gasoline contains enough energy to make my Prius go like 40 miles. That's a lot of work. Isn't that amazing? If you had to push my car 40 miles, that'd be like a lot of work, wouldn't it? That's amazing. Isn't that amazing? That's why we use gasoline, because it's so darn convenient. So try this one. It consumes 425 joules. It does 300 joules of work. What's its efficiency? Now, if you think you're going to be a scientist, leave the answer as a pure number between 0 and 1. If you think you're going to be more like a journalist or not necessarily a scientist, you can give it as percent. If you're an overachiever, you can give it both ways. Okay? There's a whiteboard. There you go. Is that percent? Yeah, does that say percent on there? I love that. Yeah, you got it.